In this problem, we are given a matrix of size m by n. We start at the top left corner, which is position 0, 0, and our goal is to reach the bottom right corner. At every step, we are allowed to move only in two directions, either to the right or down. Now, every path from the top left to the bottom right will visit a sequence of cells. For each path, we calculate the product of all the numbers in those cells. Out of all possible paths, we need to find the path that gives the maximum product. But with one important condition, the product must be non-negative. If all possible paths result in negative products, then we return -1. Also, once we find the maximum product, we return the result modulo 10 to the power 9 plus 7. But the important detail is that we apply the modulo only after finding the maximum product, not during the calculation. Now let's understand the challenge. The matrix can contain positive numbers, negative numbers, and 0. If all numbers were positive, the problem would be simple. But because of negative numbers, things become tricky. Multiplying two negative numbers results in a positive number. So sometimes a path that looks bad initially can turn into the best path later. Because of this, we cannot just track the maximum product at each step. We also need to track the minimum product. Why? Because the minimum product could become the maximum if we multiply it by a negative number later. So for each cell, we maintain two values: the maximum product that can reach this cell and the minimum product that can reach this cell. As we move through the grid, we update these values based on the top and left cells. At each cell, we consider all possible combinations and update the current maximum and minimum. Finally, when we reach the bottom right cell, we check the maximum product. If it is negative, we return -1. Otherwise, we return the result modulo 10 to the power 9 plus 7. Example 1. The given grid is -1, -2, -3, -2, -3, -3, -3, -3, -2. We start from the top left corner, and we need to reach the bottom right corner by only moving right or down. Now, let's think about the values in the grid. Almost all the numbers are negative. When we multiply numbers along any path, the final result depends on how many negative numbers we include. If the count of negative numbers in a path is even, the product becomes positive. If the count is odd, the product becomes negative. Now let's check the paths from start to end. No matter which path we choose, we will always include an odd number of negative values. Because of this, the final product of every possible path will be negative. Since the problem asks for the maximum non-negative product, and no path gives a non-negative result, we cannot return any valid product. So according to the problem statement, we return -1. This example shows why we need to carefully track both positive and negative products, because not every grid will have a valid non-negative path. Example 2. The grid is 1, -2, 1, 1, -2, 1, 3, -4, 1. We start at the top left corner and need to reach the bottom right corner by moving only right or down. Now, the goal is to find a path where the product of all values is maximum and non-negative. Let's explore the best possible path. Start at 1. Move down to 1. Product becomes 1 multiplied by 1, which is 1. Then move right to -2. Product becomes 1 multiplied by -2, which is -2. Now move down to -4. Product becomes -2 multiplied by -4, which is 8. Finally, move right to 1. Product becomes 8 multiplied by 1, which is 8. So the final product is 8. This is a non-negative value. And among all possible paths, this is the maximum. The important observation here is that even though we encountered negative numbers, multiplying two negative numbers turned the product into a positive value. That is why tracking both minimum and maximum products is important in this problem. So the output is 8. Example 3. The grid is 1, 3, 0, -4. We start at the top left corner and need to reach the bottom right corner by moving only right or down. Now let's explore the possible paths. First path. Start at 1. Move right to 3. Then move down to -4. The product becomes 1 multiplied by 3 multiplied by -4, which is -12. This is a negative value. so it is not valid for our answer. Second path. Start at 1, move down to 0, then move right to -4. The product becomes 1 multiplied by 0 multiplied by -4, which is 0. Now 0 is a non-negative value, so this is a valid path. Between the two paths, the maximum non-negative product is 0, so the output is 0. This example highlights an important case. Even though 0 may seem small, it is still a valid non-negative product and can be the best possible answer when all other paths result in negative values. In this problem, we need to find a path from the top left corner to the bottom right corner of a grid, such that the product of all values along the path is maximum and non-negative. We can only move in two directions, either right or down. The tricky part here is that the grid can contain negative numbers and zeros. Because of negative numbers, we cannot simply track the maximum product at each step. A negative number can turn a small negative product into a large positive product when multiplied again. So at every cell, we need to track two values, the minimum product and the maximum product that can reach that cell. Now let's understand how the solution works. We use a dynamic programming approach. We create a three-dimensional DP array where for each cell we store two values, the minimum product and the maximum product up to that cell. We start by initializing the first cell. Since it is a starting point, both the minimum and maximum product are equal to the value in that cell. Next, we fill the first row. Since we can only come from the left in the first row, we keep multiplying the values as we move across the row. Similarly, we fill the first column. Since we can only come from above, we multiply the values as we move down. Now for the rest of the grid. For each cell, we consider two possible directions. We can come from the left cell or from the top cell. From both directions, we already have a minimum and maximum product stored. We multiply the current cell value with all four possibilities. That means current value multiplied by minimum from left, maximum from left, minimum from top, and maximum from top. From these four values, we pick the minimum and maximum. The minimum goes into DP at index 0, and the maximum goes into DP at index 1. This ensures that we always keep track of both possibilities. We repeat this process for every cell in the grid. Finally, when we reach the bottom right cell, we look at the maximum product stored there. If this value is negative, it means no valid non-negative path exists, so we return -1. Otherwise, we return the value modulo 10 to the power 9 plus 7. This approach ensures that we correctly handle negative numbers and always find the best possible path. Let's run the solution with a few examples. Great, all the examples pass successfully. Let's submit the solution. All the test cases pass successfully. That's it for this problem. We solved it using a dynamic programming approach by tracking both minimum and maximum products at each cell. This is a very important pattern when dealing with problems involving negative numbers and multiplication. Make sure you understand why we track both values, as this concept appears in many advanced problems. If you liked the video, please subscribe to the channel. Find the solution link in description. See you in the next video with another daily LeetCode solution.